Okay, good day everyone. So today we will be discussing about indicator diagrams. So this is an old type of indicator, engine indicator. So this one is installed in our indicator valves or in our test cock or indicator cocks. And then in here we have the pressure in the combustion chamber will push the cylinder inside in here, and then pushing this part up or down depending on the pressure. And then on this side, here is a connection. So there is here is a pen or a kind of a pencil, a pen that will write something if ever, depending on how it moves. Okay, so there's a pen in here, and then this cylinder in here, we put a kind of paper in here. So we roll it on this cylinder, and then this cylinder um, will be pulled by the string, and then as the cylinder is pulled by the string, the cylinder will rotate, and then as it rotates, the paper will also rotate, and then the pen in here, it will write something on the paper. And then this string is also connected to a hook. This hook will be hooked into a part of the engine, usually at the crankshaft part. There is a hook. There's a part there in which you can hook this. You can put this hook in it, and then as the engine rotates, so that part of the camshaft also moves up and down. So as it moves up and down, the cylinder rotates, the paper rotates, and then the pen will write something on the paper depending on the pressure given by the combustion chamber in this part of the indicator or engine indicator. So, but today we already have, this was used way back, and it's still been used, but nowadays, there are electronic engine indicators and devices that you can use for your indicator diagrams. Okay, so indicator diagrams. So regular condition monitoring of a machinery is key to effective predictive maintenance. So predictive maintenance techniques help determine the condition of in-service equipment in order to predict when maintenance should be performed. So a carefully planned condition monitoring system prevents machinery failure and avoids damages to your business operations. So the combination of different condition monitoring systems into one system allows more cost-effective predictive maintenance. Okay, so this is a indicator diagram of a two-stroke diesel engine. So as the piston moves up its cylinder, pressure and volume decreases and pressure increases. And during combustion, pressure is at its maximum, so the combustion occurs. And then as the piston goes down, exhaust valve opens and the pressure moves down while the volume is increasing. And that's it for a two-stroke engine. It will rotate, so it moves every revolution. Okay. This is a video, but it's not playing, so let's go continue. So indicator diagrams. The indicator diagram is very important to know the combustion in the cylinder and also to adjust the engine. So the diagram is taken periodically from the indicator valve equipped on the cylinder head, and combustion condition is to be confirmed. So the compression pressure and maximum pressure in the cylinder can be presumed from the indicator diagram. So engine indicator is a device used to take the indicator diagram, which can be considered as a stethoscope for diesel engines. So indicator diagrams give efficiency of combustion in the cylinder, condition of the running gear, irregularities in fuel pumping and injection, and a lot of things. So this is an indicator diagram of a 4-stroke. So this is a 4-stroke. Sorry for that mistake. So it's a 4-stroke diesel engine. So as the piston moves up, let's start here from letter A. So as the piston moves down, intake valve opens. Intake valve opens, going down here. and then when the piston moves up, it starts its compression. So on this point, intake valve closes, and then compression starts. So in here, and then injection starts before top dead center, but due to injection delay and ignition delay, it will create a combustion after top dead center. So after top dead center, combustion will occur, and then pressure will go to its maximum, Pmax, because of the combustion, and then pushing the piston downwards until the exhaust valve opens, and then exhaust stroke starts. The piston moves up, pushing the exhaust outside, and then intake valve opens. So both exhaust valve and intake valve opens at this point, and the fresh air will push the remaining exhaust valve in the combustion chamber. So it is what we call as a valve overlap, or a valve overlap for 4-stroke engine, or a scavenging or flushing in other terms for 2-stroke engines. So at this point, and exhaust valve closes in here, so the valve overlap stops, and then purely intake is activated, and then intake valve closed, and then back to compression, power, exhaust. So that's how a 4-stroke diesel engine works. Okay, so there are 4 types of indicator diagrams that can be taken from the engine cylinder to know the condition and performance of the engine. First, the power card or power indicator diagram. Next, we have the compression diagram. We have the draw card, out of phase diagram. We have the light spring diagram and the pressure derivative. Okay, so let's go. Power card. So power card is taken with the indicator drum rotating in phase with the piston movement. So the area within this diagram represents the work done during one complete cycle to scale. So the mean indicated pressure is obtained from this diagram to calculate power produced in the cylinder. So this is what we call as a power diagram. Some also call this as the banana diagram because it looks like a banana. Next, we have here the compression diagram. So compression diagram is taken in similar manner to the power card, but the fuel shut off in the cylinder. So usually the fuel pump, we pull the fuel pump away so that it will not give fuel to our combustion chamber. So we just take the compression diagram in it. So the height of this curve shows maximum compression pressure. So if the compression and expansion line coincide, it indicates that indicator is correctly synchronized with the engine. So reduction in height of this diagram shows low compression, which may be due to worn cylinder liner, faulty piston springs, piston rings, or what we call as the blow-by, insufficient scavenged air, or leaky exhaust valve. Next, the draw card, out of phase diagram. So the draw card, we have here the compression diagram combined with the Pmax. So compression pressure and max pressure is combined, so that is the draw card or out of phase diagram. So draw card is taken in similar manner to power card with fuel pump engaged, but with the indicator drum 90-degree out of phase with the piston stroke. This diagram illustrates more clearly the pressure changes during fuel combustion. Fuel timings or injector faults may be detected from its shape. Okay, this is the light spring diagram. So the light spring diagram is taken similar to the power card and in phase with the engine, and with a light compression spring fitted to the indicator. So this is the compression. We have the exhaust, and we have the scavenge. This diagram shows pressure changes during exhaust and scavenge to an enlarged scale. It can be used to detect faults in this operation. So if you want to focus on the exhaust stroke, the scavenge and compression stroke, scavenging, so we can look at this light spring diagram. Next, we have the pressure derivative. So the measurement of the point of fuel ignition, measurement of the maximum rate of pressure rise following initial combustion. So this is the maximum pressure, the cylinder pressure during the maximum pressure rise following initial combustion. So there are of indicator diagram. The area of indicator diagram is calculated by planimeter, usually used on board, or mid-ordinate method. So you can calculate the area of the indicator diagram, but with the use of the current technology, we already have digital, we have already electronic engine indicator, in which after you take all the pressures from all cylinders, you will just connect it to a computer, and then every details will be printed into the computer printer. So the use of indicator or draw diagram for engine performance. So irregularities in the shape of indicator diagrams are indications of faulty engine operation. So for all units, problem may be common, like faults in fuel oil system, intake air, turbocharger, air cooler, exhaust, etc. So single unit problem could be of fuel injectors, fuel pump, exhaust valve, and etc. So the draw diagram is used for measuring the compression pressure. Here we have the compression pressure. We have the maximum pressure, this one, the second mountain, maximum pressure, and for evaluating the ignition characteristics of the fuel oil. So this is a complete draw diagram. We have here a power and a indicator card. Okay, so the indicator diagram, PPD diagram, or work diagram illustrates the pressure variation in the engine cylinder as a function of the main piston position. So the diagram area can be integrated by means of a planimeter, and the mean indicated pressure calculated used with engines fitted with indicator drive or MIP equipment. Okay, so fault finding from draw card or indicator diagram. Okay, let's start. So in here, as you can see, this is the broken line in here is a normal diagram, and then as you can see, the current diagram that you have taken has a lower maximum pressure than the original or the normal diagram. So there's something wrong in here. So as you can see, the diagram shows maximum pressure too low, but compression pressure is normal. So this is the compression pressure, it's normal. So what could be the problem? So here are the possible problem. Fuel injection too late. So if your injection will be too late, in which your piston is going down and then the injection starts now, so if it creates a Pmax or it combusts, so the pressure will go down since the piston is moving down also, so it's too late. The fuel pressure too low, so if the pressure is too low, then you cannot create or build up pressure, and then your fuel injector will have a delayed injection also. Defective fuel valve, defective, so that is not detective, defective fuel valve. So if your fuel valve is defective, it will have an late injection. Defective fuel pump suction valve. So if the suction valve of the defective fuel pump is has a problem, so you cannot activate your injector on time, or your fuel valve on time. So there will be also a delay in injection. Exceptionally poor fuel, bad ignition properties. So if it has bad ignition properties, it will not combust at the right time. It will be delayed. And then fuel pump lead too little. So if it's too little, so there will be delayed in your injection also. So that are the possible problems in this diagram. Next, we'll go with here. As you can see in here, the normal diagram, we have the broken line, and the pressure is now higher than the normal pressure. So in the diagram shows maximum pressure is high, but compression pressure is normal. So here, normal compression pressure. So what could be the problem? So fuel injection too early, so advanced injection, fuel pump lead too large, or it is on this side, it is the other way around from the first diagram. So there may be a problem in the injector or in your pump. Okay. Next. So as you can see in here, the normal one is the broken line. So in the diagram shows lower, both the maximum pressure and compression pressure are low. So both are low. So as you can see, if the compression pressure is low, also the maximum pressure goes down. But if you if you can compare the maximum pressure from here and the normal, so it's like the same, but because of the lower compression, so the Pmax goes down. But as you can see, it looks like the Pmax is normal in curve. Yeah. So what's the problem? So leakages, so increased cylinder volume or fouling. So if there are leakage in your air, so you cannot build up a proper compression pressure. So piston ring blow by. So if there is a blow by in your piston ring, so there will be leaking of air and leaking of combustion. Exhaust valve seat leakage. So if there is leak in exhaust valve, you cannot build up the right compression pressure. Piston crown burnt. So if the piston crown is burnt or there is a bigger space in the combustion chamber, so the compression pressure will also go low, become low. Low scavenge pressure, so maybe a fouled air filter of the turbocharger, or the charged air cooler is fouled, yeah, maybe, or there are problems in the flaps of your scavenge space. Fouling of exhaust and or air system, so both can do make our compression pressure low. Next, indication and effects. So abnormally high peak pressure of the unit is recorded at the top of the piston stroke. Knocking sound comes out of the engine due to heavy loads passed to bearings via running gear. So early ignition. So as you can see, the normal line is in here, and then there is an early injection, early ignition, so the pressure goes up. So early ignition causes increased thermal efficiency of the engine. Also, exhaust temperature reduces since combustion starts long before it is supposed to, but the shock loads and vibration results in damage of the engine. So it is not also good to have early ignition. So abnormally high peak pressure of the unit is recorded at the top of the piston stroke. Knocking sound comes out of the engine due to heavy loads passed to bearings via running gear. Okay, what are the causes? Incorrectly adjusted or accidentally changed fuel pump timing. So if you have a problem, you will have to adjust in our VIT or variable ejection timing. Damage or incorrectly set fuel valve or fuel injector. So if you have time in your port, so it is much better to replace your fuel injector or your fuel nozzle. So undesired fuel quality. Parts inside the cylinder are overheated. So those may be the causes of early ignition. So next we have here a late ignition. So indications and effects. So we have low peak pressure in here. You can see low peak pressure is indicated for the unit after top dead center. Combustion continued during expansion in here. There is still combustion continuing even at the expansion stroke. Give rise to incomplete combustion of fuel, loss of energy, elevated exhaust gas temperature for the unit, and black smoke at the engine exhaust. So other effects, reduced power of the engine due to incomplete combustion of the fuel and energy loss in the exhaust. So what are the causes? So faulty fuel injector or injector spring tension tightened beyond setting, poor fuel quality, wrongly timed or leaking fuel pump, engine parts inside cylinder are undercooled, incorrect atomization, compression pressure low, but if you can see the pressure is normal. So this may be not correct. Combustion air supply is low, so but as you can see, air in here is in normal pressure, so maybe this is incorrect. But it is also good to check. Always check. Okay, next we have here the after burning. So what, as you can see, after burning, there is a high pressure on the exhaust in the expansion stroke. Yeah, as you can see here. So indication effects, a rise in expansion line is recorded in the later part of piston stroke in here. So there is a rise in expansion line. Since burning of fuel continues, exhaust gas temperature and pressure increases, causing black smoke at engine exhaust. Unburned carbon deposits fouls exhaust system, cause damage to exhaust valve and seat, turbocharger surges, and there are chances of uptake fires in exhaust gas economizer. So elevated temperatures inside cylinders cause breaking up of lubrication and increased wear of liners, piston rings, burning of piston grounds, etc. So what are the causes? Low fuel combustion. Quality of fuel is less because as you can see, fuel is burned or on the downward stroke. Then low temperature of fuel means high viscosity. High viscosity means your fuel can be burned later, or it cannot be burned easily. So there will be after burning that will happen. Okay, here we have in leaky fuel injector. As you can see, the normal pressure is here, but since the pressure is somewhat irregular in this part, so maybe there is a fuel injector that has leak, so may tulo. So baka galing sila sa Brazil kaya nagkatulo. Well, just joking. Okay, reduced power in the affected unit, high exhaust temperature and presence of black smoke in exhaust, possible knocking sound or pressure waves in fuel injection system, sudden up and downs in indicated diagram in the fuel injection and expansion side. So after burning due to incomplete combustion of fuel. Okay, causes leaking fuel injector, choking of fuel injector spray hose, which leads to improper atomization and dripping of fuel or leaky. So that is for leaky fuel injector. Next, we have here a partly choked fuel valve. So the diagram is very what's this? Moving anywhere. So indication that affects low exhaust gas temperature of the unit. Power card and draw card indications, loss of engine power. So causes fuel contamination and improper purification, carbon formation at the injector tip, carbon deposits on fuel valve due to overheating. Okay, next we have here for the compression, or only for the compression. So compression diagram. Indication and effect, we have low pressure in the indicator card, reduced power of engine, and causes improper combustion, insufficient air for combustion, leaking of air in between piston rings and liner or compression stroke due to worn out liner or piston ring, or maybe on the exhaust valve there is a leaking, or blow by. Okay, light spring diagram gives indication on faulty exhaust valve and intake port operation. So as you can see, this is the normal. This is late opening and early opening of the exhaust valve. So early opening, elevated exhaust gas temperature and fouling of exhaust system, loss of engine power if there is early opening in the exhaust valve. And then late opening, reduced blowdown effect, and hence reduced scavenging efficiency. Low quality of exhaust gas delivered to the turbocharger inversely affects its operation. Okay, next we have here indications and effects for choked exhaust. So as you can see, this is the normal, and then the exhaust is nearly choked. So power loss in the unit, increased exhaust temperature, turbocharger surging, adverse effect scavenging efficiency. So if your exhaust gas is choked, so there is a problem in your turbocharger also. There will be surging. Causes improper combustion, increased cylinder lube oil. So if the lube oil is too much, it will create inefficiency. Okay, so that's it. Improper combustion and increased cylinder lube oil. Okay, power produced on the cylinder because of the expansion of gas is called indicated power. So negating any friction, heat loss, or entropy within the system. So it is known as the theoretical value of power of a reciprocating engine. So it is calculated by pressure developed inside the cylinder, measured by an instrument called engine indicator. So typical indicator diagram for two-stroke engine is shown in figure, this one. And the area within the diagram represents the work done within the cylinder in one cycle. So this area, the banana, is the work done. So the area can be measured by an instrument known as planimeter or by the use of the mid-ordinates rule. So the area is then divided by the length of the diagram in order to obtain mean height. So this mean height, when multiplied by the spring scale of the indicator mechanism, gives the indicated mean effective pressures for the cylinder. So the mean effective or average pressure can now be used to determine the work done in the cylinder. So this will be the formula, but this topic will be discussed in our classroom now. So we will discuss more on indicated power, brake power, other calculations for engine, fuel consumption, specific fuel consumption, and so much more. So that will be discussed uh, on our classroom. Okay, so thank you very much for watching. I hope you've learned something from the indicator diagrams, and see you on our next video. God bless, and please do subscribe and share our video. Thank you.